Smart Hose Technologies is an engineering company, and we design safety systems in and around hose assemblies. If plant safety is about layers of protection and your hose assembly is the weakest link, then adding protection at this link makes sense. We create layers of safety for your weak link. This presentation will run you through our product line, what it is we do, our capabilities, and the different industries that we serve. If you do have any questions, as I mentioned at the end of the Q&A, I will unmute the lines and we can have an open Q&A session. Again, you will receive a follow-up email after the webinar to the videos and that I'll be showing throughout the presentation. So if the videos do lag for you while you're viewing them, no worries. Our follow-up email will have links to them. And if you do have any sort of questions after that you want to ask, once the webinar is over, our contact information will be on that follow-up email. Hose assemblies represent the weak link in all transfer operations. Accidents happen. Hose assemblies can get damaged in day-to-day operations. A fitting can separate, a pull-away incident can occur. I have personally worked a handful of convention shows since I started working with Smart Hose, and without fail, we've had engineers or operators, end users that have always asked, hey, does this work against pull-away incidents? And you'd be surprised that it actually happens more often than it should. When a catastrophic hose failure occurs, a few seconds makes all the difference. When industrial hose assembly experiences a catastrophic hose failure, an uncontrolled release of hazardous material can lead to property damage, environmental fines and cleanup costs, personal injury, or worse, even fatality. Our smart hose system is a passive system. The hose reacts to the catastrophic failure, and there is no need for human intervention at all. We instantaneously shut off flow on both sides. So again, accidents are inevitable, but what our system can do is control and eliminate those catastrophic failures. All hose assemblies have one thing in common, and that is they will eventually fail. It is just simply a matter of time, and what determines that mean time of failure is how it's being used. We always receive phone calls from customers asking, hey Joel, how long should this hose last us? The answer is not quite so simple. The application determines the mean time of failure. And a good example is a barge hose. If a barge hose is not properly supported with slings and the weight of the hose is hanging off the connection ports, this barge hose will fail quicker due to the weight of the hose, pulling back on the fittings and causing premature failure. Another example is a hydraulic hose in a steel mill environment. Sparks are falling on it, molten splatters, there's no protection on it whatsoever, there's no cover. This hose will fail quicker than a hose concealed from such a harsh environment. Mean time to failure is directly related to the application. One perspective to look at hose assemblies is to classify them into engineered assemblies and non-engineered assemblies. An example of an engineered assembly is a hydraulic hose assembly. And most industrial hose assemblies are considered to be non-engineered assemblies. And it's important to understand the difference between the two and their associated impact. Most hydraulic hose assemblies are considered to be engineered assemblies because there's one company, one engineering team that has designed the hose, the fitting barb, the furrow, the crimp die, and the crimping machine. All of those components of the hose assembly have been engineered and designed to integrate with one another. After the hose assembly is manufactured, the working pressure of the hose assembly will be the same as the working pressure defined on the lay line of the hose. Now, unlike hydraulic hose assemblies, industrial hose assemblies are considered to be non-engineered assemblies. Typically, the company that manufactures the hose is not directly responsible for the manufacturing, the engineering, and design of the fittings, the furrows, the crimp dies, or the crimp machine. Therefore, the components of most industrial hose assemblies are not specifically designed to integrate with one another. Also, The construction of industrial hose can vary greatly. The outside diameter of the hose can fluctuate, which can affect the furrow size and the crimp spec. The fact that the components are designed to work with a wide variety of industrial hoses, and the outside diameter of industrial hoses can vary from batch to batch, this in and of itself can create an inherent weakness in the hose assembly. So just as you would think of your transfer operation being, your transfer operation and your hose assembly being the weak link, you have to think of your industrial hose assembly as a chain as well. They are only as strong as the weakest link. So a non-engineered industrial hose assembly can be derated by adding couplings attached to the end of the assembly. So for example, let's say we have a 2-inch chemical hose that has a working pressure of 200 psi, and that's printed on the lay line of the hose. An end user comes around, operator comes around, and he installs 2-inch cam lock and groove fittings at the end of the assembly, which are rated to 125 psi. That hose assembly has now been derated to 125 psi working pressure. That full complete hose assembly is now derated to 125 psi. Unfortunately, the lay line on the hose will still indicate the working pressure of the hose, which is labeled at 200 psi. And this is where it can lead to human error on the field. Every industrial hose assembly must effectively control 2 basic internal forces: pressure and end force. Both forces are present in all hose assemblies, from your industrial hoses down to your typical garden hose. These 2 forces represent a very unique challenge and danger when they're not controlled. Pressure, we all understand pressure is defined as the force applied to an object perpendicular to the surface. It's the force that is trying to break through the walls of the hose. And typically, hose manufacturers build in a safety factor. Depending on the hazardous material being transferred, safety factors go from a 4 or 5 to 1. In the LPG industry, it must meet a 5-to-1 safety factor. LPG is holded at 350 psi. It must burst or exceed 1,750 psi in order to maintain that safety factor of 5 to 1. The second dynamic found in all hose assemblies is called end force. And end force is defined as a force that travels longitudinally along the hose assembly, and it's actually trying to force the fitting out of the end of the hose. It's trying to blow it off. End force is the product of working pressure times the cross-sectional area. And what I'm going to do is going to enlarge this chart, the end force chart, larger so it's easier to see. Note that hose diameters that are greater than 1 inch, that are greater than 1 inch will always experience end force that is greater than the pressure. This is just to point out that end force is not the same as pressure. So let's say you have a 2-inch hose and you're operating at 300 psi. We go down this chart and we see that the end force is 942 psi. Understanding the different dynamics within the hose assembly, gives us an insight as to why they are considered the weak link. Engineers understand end force. Those that don't understand are mostly the operators who are handling these hoses on a day-to-day operation. I'll just go back here. I also want you to look at this water discharge table. Let's say you have a 2-inch hose, that is operating at 200 psi, and it's moving LPG. At this pressure, you have an end force of 625 psi, which is from the end force chart. And let's say it blows off the end fitting. What flow rate would you expect out of that hose or out of your plant, your tank? There's 558 gallons spewing out per minute. Now that's just for water. LPG has an expansion rate of 270 to 1. So multiply your 558 times your 2 ends, your hose blew off, and your plant pipes. You have 2 ends that are released, and the expansion rate, multiply that. This is the reason why a passive safety system is so important. The hose reacts to the catastrophic failure and shuts off the flow immediately. And the beauty of the smart hose system is the simplicity of it. Let me just go through here. I'm going to go ahead and activate my webcam just to show you a little sample that I have of how to better explain of how our smart hose system works. You can also refer to the diagram that shows at the very top normal flow. So this here is a clear sample that we use to demonstrate how our system works. And it's very simple. There's valves integrated onto each end fitting. There's a cable that runs inside the actual hose itself. And that cable is longer than this hose that I'm holding. The cable is attached to those valves that are integrated into each end fitting. And that cable acts as a spring and keeps compression force on those valves to keep them open during normal operation. It is fighting the flow of the actual, the medium being transferred and keeps them open during normal operation. So if you look at the diagrams, if you were to have a coupling ejection, a hose separation, or a hose rupture where the cable is through, our system is going to instantaneously close those valves. The back flow is going to shut off one valve, and the front flow will close the other valve. It's in the case of a catastrophic, in a pull-away incident, you're also going to have the valve closed before the actual, before the hose is torn off and before it breaks away. And let me just show you here again with the webcam. Sorry about that. It's kind of hard to hear them, but when I pull on this actual small hose, you can hear the valves hitting the valve seat and closing off the flow. So that's just an example of how easy and quick it is. The valves have already closed before the hose even lets loose, or it's separated, or the couple is ejected. Now, just on the last scenario there, just to point out, we do have a note that the cable must extrude from the hose for the valve to engage. There's a lot of several variables that can play into a part of that, but in a pull-away or hose separations, our valve will close every time. Our technology won't prevent pinhole leaks, but we do, at that point, we hope you depend on your operator or your annual inspections of hoses to catch any sort of pinhole leaks, any slow leaks. This here is a video of a high pressure hose I'm going to show right now. And like I said, if it lags for you while you're watching it, we will have links in our follow-up email to the videos. The first hose that we do is a hose that doesn't have the smart hose system in it. So it's the dumb hose, as we call them. We pressurize it to about 1600. Now our operator here is going to cut a hose that has a smart hose safety system in it. So after seeing that video, you tell me which one you'd like to be around when there's an actual catastrophic failure. Like every piece of technology, we do have our limitations. Our technology does not work on hose applications, hoses on a reel. So if you have any sort of bobtail truck applications, we do a no quote on those. on those. Another limitation is composite hoses. Composite hoses just are too pliable, too flexible. They stretch a great amount during normal operation. And our system, it needs to fight the cable. The walls need to be able to work against the cable. The walls and cables work against each other to provide that compression force and keep those valves open during normal operation. So those are the two limitations that we have: hose reels applications and composite hoses. Our smart hose valve designs. We have two different valve designs, with the third there being a small, subsection of the variation of the LL3. But the first one is our LO1. This is a poppet-style valve, it's a plunger-style valve, and that is available in our 1/4 inch to 1 inch in diameter, mostly our high-pressure cylinder filling applications. Our LO3 design is a flapper-style valve, and that's available from 1.25 up to 8 inches. And as I mentioned, our LO3-B is the same type of flapper-style design. It just has the engineered breakpoint in it, and that's available right now just in our 1.25, 2 inch, and 3 inch IDs only. Hopefully we will be expanding that line and have a breakaway for every size hose. As I mentioned, different type of diameters, assembly diameters that we have in production, all the way from down 1/4 inch into 8 inches in diameters, your barge hoses. Different type of materials that we currently incorporate our smart hose safety system: your smooth bore rubber hoses for your LPG, NH3, your corrugated metal hoses with stainless steel, your high pressure hoses, Teflon, Tefzel mostly do, and cryogenic hoses. There aren't many hoses we cannot implement our safety system in. Different applications we are involved in. As I mentioned, high pressure cylinder filling applications. We're also involved in cryogenic transfers, liquid oxygen, your liquid nitron, liquid argon, nitrogen, liquefied gases, LPG, NH3. We're also involved in the petrochem industry, your barge loading, unloading, transfer applications, and also in any scenarios where you may be involved in a pull-away incident. And as I mentioned, those are the 3 sizes, and hopefully we'll expand the line to every size hose. There are mandates for LPG and NH3. DOT HM 225. If you are unloading a large over-the-road transport and you have LPG NH3, you have to have a passive safety device. Canada Regulations B620 mirrors HM 225. Obviously, it just applies to Canada. And the 2 DOT special permits there, one applies for cryogenic and the other is for chemicals. If you are not using a smart hose, your attendant needs to be there all the time to make sure the operation is going smooth. DOT says if you are using a smart hose, your operator may attend to other tasks while the hose is in operation. They'll just have to check every hour to make sure everything is going rather smooth. You do need to apply for the permit and be approved. If your party is interested in these forms, we will fill these out for you and track these along the process. Once approved, we will notify you of your approval and let you know. For those from Air Liquide, you believe you already take a part in this. If you do have any questions regarding special permits, please, after the webinar, please feel free to contact us for that. We are an engineering company. We understand that all hoses we sell are going into hazardous applications. We take great pains to make sure everything is done right the first time. Every order that goes down to the hose shop carries 2 documents. It's a bill of materials and a router. The bill of materials defines our part number, and every bit of that part number is critical to the makeup of your hose assembly. Everything it stands for something. So if that part number is incorrect, it will be an incorrect build. The router is the recipe for the build. It defines the cut length, the crimp specifications, the crimp dies, and the crimp machine. It lets us know how much cable to put into that particular assembly. It lets us know how much force should be on the end of the valve to make sure the valves don't close in normal operation. Our QC engineer will take those documents and compare it to the hose that has been built. He'll make sure the crimp specs are correct. We'll check the crimp specs on the furrows. He'll check the force on the end of the valves, the strain, and we do that with special tooling that we've made to make sure that those valves don't close in normal operation. We check all metal hose welds and any welds that have to be made for couplers. We check to make sure that the length of the hose meets a special tolerance. We make sure that each hose has been pressure tested. And just in general, we do an overall evaluation of the hose to make sure it's free from any defects. So here at Smart Hose, we don't leave anything up to guessing. Every hose that comes out of Smart Hose technology is pressure tested. We test with nitrogen underwater. It's cleaner, it's more feasible for production, and it's easier for us to check for leaks. We're looking for bubbles. The document that you see on the right there is an example of our test certificate. And this goes attached to every hose that goes out, and also you get a copy of it in your shipping document. And this piece of document is very, very important. It carries a lot of critical information, has your serial numbers, has your working pressure, your test pressure, your design burst pressure, also has your hose part number, your hose description. And for those that keep these filed away, this section here is very important if you want to refer back to any sort of materials inside that hose assembly. It's a material cert section there at the bottom, and it tells you the makeup of each component that is in that hose assembly. We sell through distribution. This is a sampling of end users that use our products. Many of them have standardized their Smart Hose for certain operations, and others have audited and approved Smart Hose products and procedures. They recognize the importance of a Smart Hose and have spec'd them in. They are using our technology as a layer of protection at their facility. We believe quality and safety go hand in hand. We use the highest quality hose for our high pressure applications. We have hose rated for 3,500, 4,000, 4,500, and 6,000 PSI, made out of Teflon or Tefzel tubing. We also do metal hoses. Our Teflon and Tefzel hoses are post-sintered. Post-sintered is the rebaking of the fluoroplastic at a controlled time and temperature. This increases the wall thickness and tightens up the molecular bonds, and it reduces fusion and diffusion. Tefzel, everyone's well aware of Teflon. Tefzel is a more dense fluoroplastic. It is highly used for helium and hydrogen application. Our Smart Hose pigtail, our Smart Hose high pressure hoses, there are a solution throughout the world. A unique product that we have is our heat sink. Our heat sinks are used for oxygen applications. Oxygen is a dangerous application. Oxygen can generate heat, and it can create flash. It can create a flash fire. The velocity of the oxygen, speeds up, and it can generate a lot of heat. And just turn on my webcam so I can also show you, an example of our heat sink and how and where a lot of the heat generates. So this here is our heat sink. The reason our heat sink is much more effective than standard heat sink dissipators, a lot of standard heat sink dissipators go attached to the end, and they go between either the cylinder application or wherever the oxygen is coming from. That's not where the heat source originates. The heat source originates at the smallest opening, at the smallest cavity, which is right at the barb where the furrow is attached. So the reason our heat sink is much more effective is because it's at the source and it's dissipating the heat out of the heat sink rig. So this is heat sink. It imitates your radiators at home. So this is the reason why our heat sinks are much more effective. already incorporated into the smart hose system. And later on, I'll talk about safety loops, and I have a special slide for that. Another product we sell is the live swivel. You know, high pressure hoses are screwed on and off very frequently. They create a lot of torque and a lot of twisting, and this deteriorates the furrows and the braids at the crimp. And in order to deal with that, we've created our live swivel. And an example of that is a lot of operators, what they tend to do is they go and connect one end fitting to their cylinder, and you know, one end is loose, so they'll connect that end. But once they go to connect the other end, it's fixed. It'll create a lot of torquing and twisting of the hose, and we want to eliminate that with an actual live swivel. And the live swivel is easy to eliminate. We have a little white seals, and this just actually swivels for the operator to make their easier connections. We also have a high pressure bend restrictor, and what we do is, the worst place you can actually bend the hose is right behind the furrow, and the bend restrictor will take the stress off the back of the barb there, and it will move it more towards the middle of the hose, so you're not bending your hose and causing, you know, premature hose failure. Our safety loops, you know, with a smart hose, it's not really necessary, but it is another layer of safety. You know, safety loops is just an extra protection outside of the hose assembly. It's a secondary safety system. A lot of our customers have this spec'd in, and it's available for high pressure hoses. Smart hose can supply end connections, and we test the entire assembly end to end. Smart hose assemblies can be designed and adapted. You know, here at Smart Hose, we have a saying: any hose, any fitting, any application, Smart Hose can make your transfer operation safer. Whatever you are using, we can accommodate. CGAs, flare nuts, Acme, BSTPs, we will use it and test it for you. We also have scuff guards, spring guards. These are just accessories to add longevity to your hose. Hose assemblies represent your weakest link in any transfer operation, up until you have a pull-away incident. In a pull-away incident, a 2-inch tensile reinforced rubber hose can withstand more than 12,000 pounds. At this point, this piece of rubber is stronger than steel, and at these forces, your hose is no longer your weak link. You know, your weak link may now be transferred down to your truck piping, your bulkhead piping, or your plant piping. You know, this rubber hose is now playing a part of tug of war between your truck that's pulling away at the hose, or your rail car that's pulling away at the hose, and your hard piping. So in 2012, we came up with a solution for this hose paradox. You know, this is our smart hose breakaway. It is full flow, which is very different from conventional breakaways. In conventional breakaways, you have valves immersed in the middle of flow. Our breakaway, our valves are out of the way of the flow. And if you can see here in the diagram of the breakaway, our end fitting is at the end here. Our end fitting was designed with a belly. We call this part of the end fitting the belly, and the valve sits in the belly of the fitting. And that's to create that full flow. You know, we don't want anything to impede the flow. It is also, there's no maintenance on our breakaways. In conventional breakaways, usually you have those valves immersed in the medium, and you have to maintain them every 6 months to a year to make sure those valves are going to close when the time comes. There's also a significant cost savings with our breakaway compared to conventional breakaways. And I'll go a little more into detail in a few slides. Our breakaway is also proactive in the event of a pull-away incident. Remember how I pulled on the plastic hose sample and you can hear the valves closing? Well, that's a pull-away incident that you're having at that point. It's the same idea. You know, our valves are closing before the hose is actually breaking. This here is the sectional of a conventional breakaway that I was mentioning before. The valves are directly located in the center of flow. Each valve holds the other one open. The flow has to go up and around the valve, and this creates pressure drop. The design creates flow reduction. And as I mentioned, since the valves are immersed within the medium being transferred, these valves also require annual maintenance. Annual maintenance leads to costs associated with downtime and or repairs. There's also a higher cost per breakaway. A 2-inch conventional breakaway can go for $1,500 to $2,000. And end users, what they'll actually do is they'll try to compensate for the flow reduction, and they will increase the size of the breakaway. A bigger breakaway is going to be more expensive. And this piece of technology is reactive in the case of a pull-away. All right, remember how I mentioned there's a significant cost savings? Well, this here is a cost-benefit analysis that we did for one of our end users who ended up saving quite a lot. Here on the left side, this section here, is their breakdown of using a loading arm with a standard hose and then buying the conventional breakaway. And their total cost was coming out to $9,000. Now, we did a cost-benefit analysis using a breakaway, our breakaway. This is their loading arm, and this is their cost for using our hose with the breakaway already integrated into it. And their cost was coming out to $7,500. Now that's just a total savings of 16.2 there, which is about $1,500 for each loading arm. Now that's just one loading arm, and these guys were talking about tens of loading arms, which is at the end is just tens, thousands of dollars that they're saving. So that there just demonstrates a cost-benefit analysis of using the smart hose breakaway. And as I mentioned, the benefits of our breakaway is proactive, full flow, there's no annual maintenance, and the significant cost savings. Here's going to show you a demo video of our live pull-away that we did down in Miami at the World LPG show 2 years ago. As I said, if it lags for you, we'll have links in a follow-up email. The first scenario here is not a breakaway, but we're trying to show our technology being proactive. So we're pulling on the hose, and the valve, I'm going to pause it really quick. We're pulling on the hose hasn't broken yet, and our valves have already closed. We are being proactive in a pull-away incident. You have already stopped flow. And with this technology, it just doesn't get any better than closing off flow before having a catastrophic failure. That there was about 500 pounds of pull force. Now the second one is an actual breakaway, and we're breaking it at a 45-degree angle. We pressurized it with 120 psi, just shop air. Pulls back, and he breaks it. That pull force was about 840 pounds, and it's just us showing that it still held pressure. So, next logical question is, at what force does this break at? No matter what breakaway you use, there are high pull forces. It is physics, it's statics, dynamics, and strength of materials all play a part in pull-aways. And your angle of pull determines that pull force. Hello there again. This is our breakaway. And it's kind of hard, I know the webcam is kind of hard to show, but this is a cutaway view of our breakaway here. This is our end fitting, and then you have your ferrule attached to the hose. In a horizontal port connection, what you're actually measuring is the tensile strength of our breakaway. And this is the component that holds the end fitting and the hose. And you can see the groove right down the middle. That is our engineered break point. So in a horizontal port connection, what are you actually measuring is the tensile strength of that groove, all the way around in a 360 degrees orientation. So your angle, like I mentioned, your angle of pull determines your pull force. So we go and orient that into a 45-degree angle. What are you doing now? You're actually shearing that ring and pulling it off the back, and you have dramatically decreased the amount of pull force, about 85%, which is from 8,900 down to 1,300, just by changing the setup of your orientation of how the hose is connected to the port by a 45 degree. And on a 90-degree angle, you decrease it a little bit further, and what you're doing there is just you're completely shearing that ring off. So as I mentioned, your angle of pull determines your pull-away force. There are 3 reasons why we don't recommend horizontal hose ports. Obviously, the first one is the highway pull-away forces. 9,000 pounds, we really don't know whether the hose is still your weakest link. It can still be your hard piping, and we have no control over that. Which is why we recommend, a 45-degree port. Another reason we don't recommend horizontal hose ports is regarding any sort of accidental release. I mean, think about it. You have a horizontal hose port that whatever is being transferred is going out to whoever is around there. On a 45-degree angle, you're at least shooting down, kneading down to the floor, and giving more ample time for anyone who's around to get away from there. And another reason is the concentrated stress that's on the hose itself. When you have a horizontal hose port and these hoses are not in use, you have a lot of, the rest of the hose is laying down on the ground, so you have a lot of stress that's built up on the back of the furrow. And these hoses are usually, outside in open air, and you have the heat, you have the sun beating down on them, the rubber gets brittle over time, and what you get is the furrow will start digging into the rubber, and the top of the hose itself will start to become brittle, and you'll get cracks by this area of your hose. So those are 3 reasons why we don't recommend horizontal hose ports. This here, as I was mentioning, is just our test of angle of pull versus pull-away forces. We do breakaways, we do pull-aways, and we break our hoses all the time. So these numbers that I just showed you are real. We do these all the time. We do them plenty of times, and we average between those numbers that you just saw. So here's a video of different configurations, how we break, and those pull forces and how they determine your pull force. As I mentioned, if it's lagging, we have links to that in the follow-up email. I'm going to pause that video. That's a horizontal hose port connection. Look at how much that rubber hose stretches. It's getting really, really small, and it acts like a rubber band. And in horizontal hose port connection, like I said, if this is happening with our technology, with our breakaway, our valves have already closed. That's about 8,900 pounds. This is a 45-degree pull away. And that's just showing that we're still holding pressure. Our breakaways are very robust design. We've dropped our breakaways thousands of times and to no leaks. So it's a very, very robust design. The Smart Hose breakaway adapter. We recently came up with the adapter for a special application that an end user had. They had articulating loading arms with swivels and joints that don't utilize hoses, but they still needed a breakaway protection. So we provided them with the adapter as a solution. This can also work in any pull-away situation. Works the same way. There's just no hose. It carries the same benefits: full flow, no maintenance, and it's very cost-effective. Smart Hose University, we recently just established this. It's a very great online training tool. I suggest you go right after this. I mean, it has covered everything I went through this webinar, but it's really great for showing, our distributors and showing any end users or engineers that, just to make them more acquainted with our system and how it works. You can go on to smarthoseuniversity.com or go on to our generalsmarthose.com website, and it will have a link sending you to the university. We are hose experts. We are an engineering company. Our sales team and engineering team will review your applications and make recommendations. But we ask of you, if you do need any support, you contact us. If you need any literature, any sample kit, or you want to schedule one of these webinars for your sales team, we are more than willing to do so. If you want to do joint calls for specific customers, we will also do that. And the demo that we did at the Miami World LPG show, that video that you saw, we can also send that demo if you're doing an open house. We will do a live pull away for your customers. I thank you very much for attending.